Now we're going to finish limits at infinity and discuss the definition of a limit at infinity. You're really should be pretty experienced with them at this point. Let's start by looking at a real-life application of oxygen levels in a pond. The function of the oxygen level in a pond, in this particular pond, follows the function t squared minus t plus 1 divided by t squared plus 1. Now, the question is, what happens as time goes on? What percent of the oxygen remains? Now, let's start by looking at discrete points. Let's look at t equals 1 second. Or it could be a year or a month, depends upon your scale. But in this case, let's look at 1 second. All right, f of 1 is what? 1 squared minus 1 plus 1 divided by 1 squared plus 1. So this is 1/2. Now 1/2 of your original amount is 50%. Okay, so that's about right there. Now let's look at f2. So this is 2 squared minus 2 plus 1 divided by 2 squared plus 1, which is 3/5, or 0.6, which is 60%. All right, let's jump on up to f10. This is 10 squared minus 10 plus 1 divided by 10 squared plus 1. And this is 190. So it's 91 divided by 101, or about 90.1% at 10 weeks. So you can see why this is valuable. Let's look at the limit as x approaches infinity of my function. T squared minus t plus 1 divided by t squared plus 1. I lost my plus sign there. Okay, now let me divide by the largest power. And what do we have? I'm going to multiply by 1 over t squared, numerator and denominator. So I'm going to look at, I switched to x there, didn't I? The limit as t goes to infinity of 1 minus 1 over t plus 1 over t squared divided by 1 plus 1 over t squared. Let's see, that goes to 0, that goes to 0, that goes to 0, and I'm left with 1. So this is a model of a real biological environment. Now let's just look at the definition. Oh, excuse me. Let's let you do a problem. All right? Pause the video, and when you're done, start it again. Now let's look at the definition of a limit at infinity. Let's let f be a function defined on some interval, a to positive infinity. The statement, the limit as x goes to infinity of f of x is infinity, means that for every positive number m, there corresponds a number n that's greater than 0, such that if f of x is greater than m, then x is going to be greater than n. Or basically, no matter what you do, f of x is going to increase in an unbounded way. Now, what do I mean when I say the limit as x goes to infinity of f of x is negative infinity? That just means there's a negative number m that corresponds to a number n, such that f of x is going to be smaller than m whenever n is less than x. Now let's look at these limits at infinity. You can look at this graph and see as we go up to infinity, this is going to shoot off pretty high, isn't it? All right, so the limit of infinity of x to the cubed is going to increase without bound. So we can say that this equals plus infinity. Now remember, infinity is not a number, it's a concept. And it just means that this limit is increasing without bound. If we go to the left, what happens? The function becomes larger and larger and larger. And we can see it approaches negative infinity. All right, now you try these. Now, what do we do if we have these functions, these limits at infinity? All right, now let's look at this function right here. And doing the same thing we've been doing, let's multiply, I need my pen back, both numerator and denominator by the largest power of the denominator. So we'll multiply by 1 over x or 1 over x. I know your book does it a little bit differently, but that's okay. We've been doing this, so I want to continue doing it this way. All right, so this is 2x minus 4 divided by 1 plus 1 over x. Now look at what happens in here when I just take the numerator and the denominator. The limit as x goes to infinity, goodness, my pen is all messed up, of 2x minus 4 divided by the limit as x goes to infinity of 1 plus 1 over x. Well, this numerator is going to go to infinity while the denominator goes to 1. So this is going to become unbounded. In pre-cal, you probably said this does not, the limit doesn't exist. As a matter of fact, you can see it approaches a slant asymptote. Whenever you have a slant asymptote, you're going to wind up with an unbounded limit. What about when x goes to negative infinity? Let's do this one a little bit differently. Let's do some long division here and take x plus 1 into 2x squared minus 4x. Well, this is 2x, so that's 2x squared plus 2x. Change sign, so it's minus 6x. All right, so that's going to be minus 6, so it's minus 6x, minus 6, change signs, plus 6. So this is plus 6 over x plus 1. So this limit becomes the limit as x goes to infinity of 2x minus 6 plus 6 over x plus 1. Now you can see that this will go to 0, this will go to 6, but this will become unbounded. So infinity minus 6 plus 0, well, is just unbounded. Now I'm going to negative infinity, so that'll actually go to negative. All right, you give it a go. Whoops. You try these. When you're done, finish your homework.